Hello, this is the screencast documentation of the experiment about the determination of the caffeine content in an energy drink. Um, Based on the theory we have made an hypothesis about this experiment, which is that the energy drink should have an absorbance placed between solution number 4 and 5 because it has a caffeine content on 320 milliliters per liter and of course the absorbance should rise depending on the caffeine concentration. And the purpose of this experiment is to be able to determine the caffeine content of an energy drink. And in this experiment, we are dealing with some chemicals that would be dangerous if they are a clean concentration, like pure caffeine and pure iodine, but we are dealing with some smaller concentrations, so they aren't that dangerous to us, but we of course should not swallow it and eat it, and that would be quite harmful to us. Yeah. Yes. And in this experiment, we will be needing spectral photometry, which is a method to measure how much chemical substance is absorbing an amount of light that's been sent through it, based on a wavelength of light and light distance it travels in this micropipette. Um, yeah, so it measures how much light has been lost from the amount of light that's been sent out. Um,
And to measure that, we will use Lambert-Eve's law. It will show us the linear relationship between absorbance and concentration of an absorbing substance. The general Lambert-Beer law is usually written as A to epsilon lambda multiplied with B multiplied with C, where A is the measured absorbance, A lambda is a wavelength dependent absorptivity coefficient, B is the path length of the cuvette, and C is the analyte concentration. And the procedure we used to find our result was to first up find 6 microtubes which were marked with numbers 1 to 6, and the seventh microtube was for energy drink, just only energy drink. Then we put 1 milliliter standard solution to 1 microtube and marked 1 using a micropipette. And we repeated this with all the other 5 standard solutions. Then we transferred 1 milliliter energy drink into the microtube marked E, and then we filled with 0.200 milliliters of 0.050 molar iodine solution and 0.20 milliliters to molar sulfuric acid to each of the 7 microtubes and mixed it well. We waited a couple minutes for the reaction to proceed, and then we centrifuged the microtubes for 10 minutes. Then we took out the supernatant and we suspended the precipitate in 1 milliliters ethanol. We mixed it well and transferred the 7 solution into 7 microcubettes.
And of course after that we measured the absorbance. So here we have the results we have gotten, and from those we have here made a graph, a standard curve, and found out the correlations coefficient, which here is 0.9598. That might have been a problem because actually there's a rule saying that for the method to be completely valid, your correlation quotient has to be at least 0.98. So yeah, that may be may have caused some fault measurings. After that, over here we calculated or made a test to see if the extinction coefficient, which we have calculated to be 0.0002 liter per milligram multiplied by centimeters, is right, is correct. So here we just put it into to that Lambert-Beers law to see if the coefficient gives us the right result, which it did, because we have over here the extinction coefficient multiplied by the path lengths multiplied by the solution, and then we have the test over here, the graph, where we see the absorbance over the caffeine content, and that should be an absorbance on 0.02. Further down we have the calculations of the energy of the caffeine content in the energy drink, where we have Lambert-Beers law again, and then we have just rewritten the formula, so it now looks this way, where we have the substance equal the absorbance over epsilon lambda multiplied by the path length, and we have the absorbance measured from the energy drink from our experiments, which were 0.07, which accurate for our hypothesis is placed between number 4 and 5 over here. So that was correct. And further down here, when we put it into the formula, we found out that the energy drink actually had a content on 35 milligram per 100 milliliters, where we have written and where we read on the back of the energy drink, it was saying that it should have a caffeine content on 32 milligrams caffeine per 100 milliliter. So actually we can conclude that the method might be quite valid, or is quite valid, and our final conclusion is that we have measured the caffeine content in the energy drink to be 35 milligrams per 100 milliliter in final.